Welcome. In this video, I'm going to start talking about reactions that different functional groups or homologous series tend to undergo. And from section 10.2 of the Brown SL chemistry book, they talk specifically about reactions with alkanes, alkenes, alcohols, and halogenalkanes. So I'm going to start with one of the reactions that alkanes tend to undergo, and that's combustion. By far the most common use of alkanes is burning them for energy, either energy to, drive your car or some other vehicle, planes, trains, automobiles, or burning them for the energy to heat your home, create electricity, other things. So what is it about alkanes that make them so good for combustion? Well, the general formula is CnH2n plus 2. Because think about it, each N carbon is going to need 3 hydrogen, and each inner carbon is going to need 2 hydrogens. So if you have, 10 carbon, you're going to need 2 times 10 or 20 hydrogen plus 2 more for those 2 end ones. And even if you're branched, it doesn't matter how many branches you have, this formula will still hold true, because when you branch it, now that carbon that the branch comes off of only needs 1 hydrogen, and its other hydrogen goes with that branch to give it the CH3. So really, when you think about alkanes, there's not really a functional group. The functional group, or the defining characteristic, is the lack of a functional group, or all the single bonds between the hydrogen and carbon. So again, saturated hydrocarbon means all the bonds are single bonds. Saturated, remember when we talk about solutions, means you're holding all you can. So the hydrocarbon is holding all the atoms it can. You can't bond another atom on. You're going to have to substitute to get anything else in. It contains hydrogen and carbon only, hence the name hydrocarbon. So what are some characteristics? Well, both the carbon-carbon and carbon-hydrogen single bonds are quite strong and quite nonpolar. So alkanes in general have low reactivity. It means alkanes are really stable, so they can be compressed, like propane is compressed, butane is compressed, natural gas, methane is compressed. That's very safe to compress it, store it that way, transport it that way. So they're very safe fuels to use. And then when you do combust them, they release a lot of energy because of the stability of that reaction, of that bond. So the two major reactions are combustion, and then the one we'll look at in the next video is another substitution called halogenation. So let's look at combustion. As I mentioned, it's widely used for engines, for transportation, or to heat homes or generate electricity. And the general reaction is that an alkane combines with oxygen, combustion, and the products are always going to be CO2 and H2O. And again, it's going to be highly exothermic because a lot of energy is released as you form the CO2 and H2O bonds as compared to breaking those carbon-carbon and carbon-hydrogen single bonds. Other hydrocarbons like the alkenes, the alkynes, and the arenes can also be combusted for energy, but they are going to burn much sootier than what an alkane does. And that's because with those particular hydrocarbons, the carbon-hydrogen ratio increases because there's less hydrogen in those. And when you have more carbon, that's what soot is. You're going to have more carbon that doesn't get combusted, leaving behind a soot. So combustion reactions, we talk about complete and incomplete combustion. Complete combustion is ideal circumstances or conditions when oxygen is in excess, so all of your hydrocarbon is going to be consumed. So when that occurs, only CO2 and H2O is formed. But if you have limited oxygen, then you're going to have some carbon monoxide forming as well with the H2O, and we call that incomplete combustion. And if oxygen is really limited for some reason, burning the alkanes can form just carbon or soot in the water. So I've shown you the reactions for complete combustion of propane, incomplete combustion of propane where it's carbon monoxide being formed, and then really incomplete combustion where you're forming carbon or soot. And if you look at the balanced equation, you see that the ratio of oxygen to propane decreases from 5 to 1 to 3.5 to 1 to 2 to 1, which is showing you that as oxygen becomes more scarce, the reaction has to adjust and form new products. Now, regardless of whether it's complete combustion or incomplete combustion, all four of these products from burning hydrocarbons, carbon dioxide, carbon monoxide, carbon, or water, have environmental implications. Even under the best of circumstances, when it's complete combustion, carbon dioxide and water are still greenhouse gases, which means they absorb the infrared radiation that's reflecting off the earth and heading back out towards space, and instead they absorb that radiation or that heat and trap more heat in our atmosphere. So it's similar to a cloudy night keeping the temperature warmer, or a blanket on the bed keeping you warmer. Carbon monoxide is a pollutant which binds to hemoglobin in place of oxygen and is irreversible, so that can be fatal if your carbon monoxide levels get high enough. And then carbon is a solid or particulate, so it tends to clog up your engines, but it also produces soot, and those particulates, especially if they're fine particles, can get airborne and form smog and air pollution. That's not only very bad for your lungs, but it's linked to global dimming. And global dimming is an interesting phenomenon where there's actually so much debris in the air or the atmosphere that incoming sunlight gets reflected back out before it ever reaches us. So we got a lot of issues going on with our environment right now. So that is the combustion reaction of alkanes.